Now you can see what you must see. As I mentioned, my name is András Tevesz. I was here during Hacktivity 2009 and I presented a similar topic. When I tested Rootkit with a virus killer, I collected all sorts of components and put them together into one. The final result is depressing in one word, and in several words it will be explained. How many of you use Windows, and how many do you have rootkits or as antivirus devices? One person doesn't have a virus. It is one person can be quiet because he probably have a den of viruses, den of thieves, den of viruses. Okay, let's move on. After the presentation, we will have some discussions. My agenda is about the antivirus test description, what the test environment was, what test tools are used, and what I wanted to do against the antivirus devices. Did they withstand? They were fighting a little, but then they failed. And then some technical things. It must contain a little kernel code that it makes sense, and then self-protection comes, how it should operate in a well-groomed antivirus program. And then there are two to three firms on the markets who really implement this out of the 41. My test environment was VirtualBox, WinBug, kernel detective. Everything was killed with the exception of Windows debug, with which you can do kernel debugging through virtual and serial types. If you just make your Windows fall in kernel mode, then you can see something, not only a blinking screen. Kernel detective is a good old device or tool. We can monitor loops, delete drivers. Kernel detectives are against rootkits, but here we will use them against antivirus products because they do not follow rules, standards. They work like rootkits. They do bad things. And there is an ARM test rootkit which is part of the test. My test was a load of the rootkit, and then I try to unload it to clear it away. Sometimes I failed because if we hook into the system table, then when we clean up the place, then we run into program and the whole thing will just go down into hell. If you ever run a copy from the table, and if there is some inconsistency, then very strange things will happen. It will freeze during demo, because that's what happens during demo. The next parts, I want to remove kernel codes belonging to the EV product. There was no resistance here, and I wanted to check if the antivirus will restore its own hooks. And if they function, what can they do and what can they do better? I wanted in the end try to kill their services. They should be protected, but in real fact they are not so very much protected. It is not the most recent system. Support is still 60 to 65%, so the attackers will probably attack this kind of system. If with a 64-bit Windows kit problems would arise, so the whole situation will be much more difficult. During a future presentation, we will be able to try it out. I will have some videos from AV products, and at the end, I think I'll have an asset demo, but then we should just wait till the end, and in a few pictures how these things operate, what they can be used for, and how easy they can be cleaned away. They try to unpack themselves a sys file which is stored in a binary resource. That was the company who used it more frequently, more widely. We load it into the kernel. We started, our kernel code has already started by then, performs its own task, make a task manager processor disappear, and it will hook itself to task manager and will put away those files where we can see a double underscore. Task manager will be linked out from kernel object, and it will also be filtered out among the other things. This first picture was taken half an hour ago. This is the maneuver and the reaction of AV products. Those who advertise themselves that they can cope with unknown codes well, you can see the results. Again, this person is very, very quick. He keeps flashing the slides and it's very difficult to follow. And this is another version that they bought somewhere down here. This can be identified as real code. Whatever is unpacked is here, and kernel code is loaded, which is again not a normal mode of operation. Video demo, I don't know how much you can see it. This is the task manager process, which will disappear from task manager, will disappear from the list. Let's see what's gonna happen. This is the task manager process. Rootkit is loaded, task manager disappears, task manager runs on. The Norton product says that everything is okay and safe. It was updated 2 days ago. And this is the end of my demo. That was the Norton product, which has done this much against our rootkit. The other supporter is Hacktivity. They will dislike me after this. Similar things will happen. Task manager process disappears. We cut out or thrown out rootkits, and then there will be a photo for a separate product, sys inspector, which will just search through kernel memory and lists running processes. I assume that this product is capable of doing meaningful work, and will take out something that is otherwise not possible in a normal environment. It inquires about the mix environs, about running processes. This is a Commodore product. This is the one that did something useful. Rootkit is loaded first. What do we want? It asks me. And then we had an access error, but if we enable it or allow it, then it will be loaded. It can be, the task manager process can be seen. The problem is that Commodore doesn't say a word about it. We can see that it is loaded, it has been noticed, but doesn't give the user any warning, because it's a kind of schizophrenic type. Either it runs or not, or both. Either the kernel code is loaded, or the kernel code itself is being loaded. And AVG is the last antivirus product. It has a real rootkit search code. Doesn't notice anything from loading. And if we would just kill running processes of AVG, we didn't do this, and then it shows that there is a hidden task manager process, and Pickpocket really shoots it down. I don't know why I wanted to put it here in the end, or to the end of the whole list. I wanted to use up this 1.5 minutes till the whole anti-root program lasts 10 to 20 more minutes. AVG finds the program, but before that he has no proactive defense against it. So, in other words, we can't really use it. And this is the end of my video demo. This is the list of a more extensive list of antivirus processes: proactive, defense, and self-defense. Antivirus should be processes that cannot be easily killed, since they are security products, and they should guard around security with proper resources. The next file will be shown. Black parts are those black boxes where nothing happens. It is quite depressing. These are only those products that came to my mind. This last MSSEC ESSV2 advertised itself, and it doesn't do anything in spite of the advertisement. No hooks at all. From this table, two important things can be read. Originally, hooking, according to Microsoft rules, shouldn't exist in the system, because it is a modification during the running of the kernel mode, which may lead to other problems. Only the AVG and Microsoft product doesn't do any hooking. So they followed whatever was prescribed by Microsoft, or they observed the rule of Microsoft. It is interesting, it's quite obvious from Microsoft, but it is quite strange from AVG, self-defense. Whenever I kill a service, then this service is capable of starting itself. An AV should have several services and processes: a system service, a kernel service, a user process, and they should protect themselves in concentric circles. So if one disappears, then it should be restarted, because the system shouldn't fail, because we must communicate through the system. Only Kaspersky product was capable of this, yes. If antivirus products hook, then they should protect their own hooks, and whenever Rootkits gets in the system, and then it will override exactly the same functions that will be used by antivirus. If antivirus product doesn't implement a regular filter driver, only access through the hook, then if I write a rootkit, I can kill the antivirus, and there will be no feedback about any maneuvers with the files. It will just stand still and stares and says nothing happened.
Which is no good. And when there are no hooks, it's a bit complicated. In the other cases, when there are unprotected hooks, in moments the whole system defense can be disabled, and the user is happy because they believe they're safe, but nothing is happening in the background. The restore system file would specifically means that if I delete a system file in the system as part of the antivirus product, I would expect the antivirus product to note it and put it back. But it seems to be my expectation only. Even if I restarted the system, I should notice that there is one missing system file. Unfortunately, that's not the case. These are the 5 products that at least told me that they had some sort of sole problem in the background. When system files were missing for the system, nothing is happening. There is a graphical user interface, and we feel safe. There'll be many interesting photos and videos, but nothing else can really take place. Well, the Microsoft product will ask you whether you want it restored. And then it will continue to ask about 15 times because it is unable to restore it. Now, Virus Buster will let you know that you'll encounter problems because there's some gimmicks in the background, but then you close down the window, and in the main window you can feel great because you believe that you are safe. Trend Micro was the only one that properly notified the user. Avast, the sys file deletion or failure to load, that triggered a response, but if it lost the hooks, it failed to notice. Losing the hooks is difficult to detect unless restore has been done. But if you do things wrong, then at least you should not disadvantage the user. That was the test environment. The Avast product will follow. I'll show you photos of how many hooks were implemented in each of these systems. The weirdest thing was they had no consistency of what they would hook onto, what they latch onto would be like Christmas and Christ Mass. Some of them would hook onto anything, or maybe just 15 hooks. That's Avast. I wonder if you've come across these functions: query, key, open event, the anti-load driver. These are the interesting ones, and this will keep you from loading kernel code. But if at least we could catch one of these, it would be better. And Trinate and anti-codes, these are the file endings. So in principle, you could implement proactive protection through the hooks. So antivirus products latch onto them, but they fail to use them as we go ahead. Well, I had a variety of tests using a fuser type application. I attacked the function calls and checked what if I attach random parameters to these system calls. Blue death was one thing that happened, and a few cycles that disabled the system to leave the hook. And we could check that using an alternative method, but unfortunately I didn't have enough time for that. Here's the Avast product, which appears to have lost most of its file scanning capabilities. 37, the anti-create file, that would be the call, and it should be read. So it should be hooked to Avast, and Avast did not really notice this. If we delete the kernel codes, we get this nice window. We say, let's click on the Start Application button. I clicked several times, and I get back this window because it can't, in actual fact, start the program, but it will at least give you some information. Komodo, I think, was one of the quite good products. As you can see, it doesn't have so many hooks, but it's quite a number. Defense Plus, the proactive defense part was lost when the sys file was lost, but it could not restore. Diagnostics would tell me that there is a problem in this regard, but it was impossible to restore the file. ESET failed on a few points only. It identified a few hooks only, but it defended them quite well. It fails absolutely to notice the sys file deletions. You can see my codes are uploaded, and I hooked onto the two functions. One would be required for a file query, and the task manager, the process information. And ESET is telling us that we're absolutely safe, even though it cannot do anything about our safety. If I bring in a normal virus, the on-demand scan file solution will not recognize this because it won't go through the hooks. It doesn't have the hooks. So we'll sit there and watch the virus creep inside our system whilst ESET assures us that we're sitting in safety. And this is the SIS inspection. It took a few minutes. I mentioned this before. It scans the system, registers, and we should do some more research into what sort of information it's gathering. But I guess it's based on a memory dump. That's what I thought. It turns out it's through some user API query, and it can only save those. Task Manager was running in the background in principle, but unfortunately none of that is seen here. And of course the rootkit was uploaded. F-Secure is a weird product. It did something strange. It didn't have that many hooks, but it did have some, and loss of sys file resulted in this. What should I say? We're sitting there watching the status, but we can't see what sort of a status it is because there's no error message. So developers managed the errors very well, but they should indicate something in the middle of the window rather than the big green icon on the left, because it's not true. This was off mic. It's probably something that cannot be changed from inside the software. G-Data was another tested product. Why I left this screen image here, I don't know. Well, that was an interesting product because when I shut down its process, the whole system crashed. It hung up. It froze. It was either proactive, since if I can't work, then the whole system should not work either. So either that or the virtual machine had a problem, the Kaspersky. It's a large resolution window, so I've only included the gist, and they really correctly give me all the notifications. If I restore to NTTLR, then it will in 2 seconds restore what needs to be restored. Well, in principle, you should not use reverse engineering, but I was interested in how this was done, and I took apart the sys files. And the result is when ERP handling takes place and there's a dispatch call, they will check whether the hooks are in place or not. And if something is not in place, it will replace them, put them back. But the GUI function calls are also managed here, the system service description table and the system service table shadow also come up. Shadow is weird because it's part of the GUI calls, it's not a real shadow. So when you create a system level window, and I mean you go down almost to the kernel, so in Windows management takes place in the kernel, so that's the level. And also if you look at the top item, number 13, memory copy, I have no idea what this is useful for unless it's for OCR when I'm copying, and then it will search my data. So I have no idea what the use may be, but they will try to defend these processes. And on the right, if you click on status, I'll move the mic aside. So you can see in the status that Kaspersky is the only one that made the user unable to access its own processes. And after the counting of processes, it appears that if it opens the process and it notices that they're not Kaspersky processes, it provides an error code on a random basis, so you feel bad about it. And if you want problem management, you freeze. Here's the Microsoft product. In principle, that's 4 to 5 antivirus product scanners merged as one. And the claim is that they have an anti-rootkit solution. The fact, on the other hand, is that this is marketing hype, and I don't think they actually have it. Here's the turn on button, and I've deleted the sys file from behind it, and I would click 4 times on the turn on button. We'd wait a while, and then it turns back to bright red to make me feel quite unsafe. Norton antivirus. They did this weird thing. There's the sys file, which is visible, and the other one is the sys file called dash. And they tried to protect something, probably, and they did such a good job that I had to issue the dir command in the directory to see the other one. But the visible sys file can be deleted, and that actually undermines the system, and the other system file can just as easily be deleted, so I don't see why the developers took all the trouble. And these are the function calls. Trend Micro, the product. This is a 400 kilobyte setup or install pack, and I was glad because at least I thought I have a product that's not 150 megs. And then it played a nasty trick on me, because it would then go out to the web and download some 160 megs worth of install files. Moving on. Have I? I've moved on. It lost the sys file, and very decently it let me know. It brings up a window, but unfortunately it fails to restore the file. All the products I've checked has its own copy in its own directory. I did not tamper with those, thinking that they may not have any other copy, but they wouldn't even try the restore on that basis, so they don't do consistency check. Even though they have the sys file in there, they can't restore, and let's just hope that users don't misbehave and screw up things, but they do, especially if they're as bad as me. That's the virus buster. They use a sandbox sys file, or they bought one, and I could still manage to delete the sys file. It did not reduce. Neither did the sandbox. So that was the one where I would restore the system after losing the sandbox, and it tells me that it can't boot up the system because it can't find the drive or upload the system files. And it brings up this window. The virus database is a bit outdated, but everything else is great. Firewall running, self-defense running in the system defense level optimum. Well, my point of view is that it's really optimum, but not from their point of view. Resident malware protection, it's not working because the return value was never checked. Someone forgot about that. And I mentioned hooks. Let me give you some explanation. So I said that I could cause the systems to crash checking the hooks. So what's the big idea about hooking? Why do developers want to use that, and why is that bad? Why is that wrong? That is, most problems occur because developers get inside some kernel code and they want to use the normal method to check the parameters. In the normal bad memory addresses, you get access violation and the application will stall or give you some error code. Now, if you're in the kernel, then it's blue death. You freeze. And the old experts know this very well. Newer experts know less about this because the loopholes have been mostly patched. And in the service table, the functions can be replaced to our own functions. We change or modify something. We screen out a file name that we don't want to show, and we return the process to the original function call. And it will look for the file and check if it is there, and then do as it pleases with it. But I cut in and tell the user that, dear user, these are not the files that you are looking for. Here's an example. Well, the beginning will be struck by ... so it's not that important. You want to open up a file, that's not the important part. The last two bottom lines are the important, because in the extension attribute, I will say that this file is a protected file because it wants to be protected by an antivirus application. So in the EA buffer, I would have this might protect attribute parameter, and the check attribute function will check that if I wanted to do so. And the result is, if the buffer points to the wrong place, because in the user space somebody played a trick, or somebody tricked it from the kernel code and called it using the wrong parameters, the access denied will become blue death and cause the system to hang. And then it occurs to you that something should be done. One option is, let's try and catch that exception event. It's mostly useful. Well, the ... exception handling is the last resort, because then you can tell the user something evil happened. In kernel code, this is only a half solution, because if the kernel points to the wrong memory area, you get access violation. Try catch is the function that handles this, but if it's the very wrong address, absolutely incorrect, then you get blue death, unfortunately, in this case as well. So the next thing, the important thing, is the user assigned memory areas that system calls will give you as parameters. The L buffer, for instance, is probably one of these user supplied parameters. It's not in the kernel, but in the user memory. And meanwhile, it can be changed at any time. So let's say the user has several threads running under the application. The area can change several times until we get to the point where we read data. It's changed 3 times meanwhile. The probe for read, probe for write, and probe and lock would take care of that. So in principle, you should call that before execution. If I do that with IOCTR handling, I should check whether the parameter is correct and can be read. In the case of probe for write, I should check whether it's writable and with the proper length that I need, because if that's not the case, and if I write to the wrong area, it's again blue death. And here's the corrected code. It does quite as expected. First, it will try to check whether the memory area is readable. Let's just hope that interruptions don't crop up that it cannot handle. And let's say during the copy process, it could be interrupted, especially if the user has changed something. User memory is subject to change, so we should back it up in some way or other. Meaning, we need to have our own copy of this memory content and then use that copy to make changes and run the checks. And that's something difficult to control by the user. It's impossible to control by the user, by the way. So this code first checks the length, and then it will see whether the area doesn't mismatch, conflict with the file size that we want. Then we check whether it's readable. It will copy the content out. We memorize the size, and a probe for read is going to return the value, and it's not blue death, but an exception error. And the code can handle this error condition. And then we execute our actual operation. If all antivirus products were based on these codes, fusers could not give them the blue death. I don't have that specific list because running a fuser took 2 to 3 hours, because there were something like 40 functions, and a few minutes with each would give you quite a long time. And if you take 15 products, you would get way beyond the time limit. But I could take care of a few of the products that I checked. When I get enough time, I should probably develop a standalone presentation on this. So the probe for read example was important. The probe for write is just as important, because the areas should be checked as close as possible to the relevant part, and the interrupts should be suspended. Whether to hook or not to hook, that is the question. And I said at the beginning that hooks may not be the right idea and something else should be used. There's kernel batch protection that Microsoft uses and digital signatures as well. If we don't have a 64-bit system, these unfortunately don't work. On 64-bit systems, the virus buster must use that unless the system is cracked and system-level changes take place. And in the case of a service pack, this will result in a nice blue death and an angry user who will not understand that they have a properly working product and the service pack, and why an antivirus application would cause the system to freeze. I think they should backport these solutions from the 64-bit environment to make the systems safer. The processes reveal what's for what they hook to. Process creation, process termination was one of the issues. You can create threads as a solution, or you can load DLLs, or you can duplicate all sorts of data, and the registry protection, that's one of the key things. Because if you get a registry callback, we need to decide whether to let the user override the registry or not. Well, we've spoken to a number of antivirus developers, and they told me that what I wanted to do with the rootkits and the kernel, and I wanted the rootkit out of the kernel, and if I'm running Windows XP in system administrator mode, it should not be that easy for me, especially since I'm paying for this product. And by the way, I'm not using antivirus products because for the Linux environment there are hardly any. For Linux and OS X there are just a few, but they actually check the files. So these problems in a Linux-based or OS X-based system, the problems would still be valid, except that the hooks are set up in a different way, so errors will be different. But if you are using Linux or OS X, you shouldn't feel too comfortable. I wanted to have a demo originally, OS X code or Linux kernel code when they are loaded. That's also a risk, but I decided to skip this. So this is where we are. Self-protection based on research and the data collected, what would be useful and what we should have to be able to regard the system as safe, rather than missing all the sys files and still believing that we're safe because we see a green symbol. The sandbox should be working properly, because if I started a process, I should be able to check what it will do, and it should not be able to do anything potentially dangerous, because normal user processes should not upload sys files into the system because it's simply dangerous, and for some reason it is allowed. And it would also be important for antivirus products to show us some features regarding self-protection. If we get a malware based on a browser, it will be able to shut down most of the antivirus products, because when we run the code, it will find the antivirus product, it will upload its payload, and then you get an infection, and the antivirus is disabled next time you boot it up, and the system is running and the mail is running, but we're part of a zombie network.
Self-checking, it is also important that nowadays there are several rootkit solutions spreading that modified a little of the sys file, and they linked themselves to a sys file. It is more dangerous because if something is mishandled here, then the whole system will fall. And then it is still capable of putting rootkit codes underneath the operating system. it will be loaded, and we don't have to wait till a CD gets into the machine. It is quite sure that AD will start at the beginning of the whole process. Process protection. The first thing is that the user should not be able to stop process which is responsible for our defense. User is a wicked person, not a normal user. Avoid DLL injection. Oracle presentation mentioned this. If we are in an address space of a protection, then we can save passwords, do whatever we want. We may move over the firewall, open up new links over the firewall. Avoid open process. Open process is capable of opening any Windows process, and then I'll give you a remote thread, and then put it into your own address space, run it, and we are waiting for the result. If a code fraction is run, then we can do whatever we want, we save messenger passwords or whatever else. Avoid global hooks. It's again a system service. Originally it is invented to reinterpret keystrokes. For example, in the case of a Chinese character, we need the stroke of several keys, which is solved through global hooks. So global hooks is a good monitoring of keystrokes, because global hooks are automatically loaded into the address space of every process. We shouldn't ask it, it will be automatically loaded into the address space. File protection. There are two kinds, active and passive protection. Active is very difficult to implement. Filter driver is needed to check what kind of files are accessed. If it's our own file, then we should leave it. If it is a protectable files to be protected, we should leave it. We shouldn't shouldn't delete it. Passive protection. We have an integrated checking on a sys file. While is a sys file loaded, which is modified, it has a checksum, and we can override this checksum as well. But we still should try to take a look at it. Driver protection, again a difficult issue. If you are in kernel code, you can do whatever you want. So we should actually put an obstacle into getting into kernel code. There are 4 or 5 methods. Some are functioning, some I tried but don't function, but there are 4 or 5 methods with which we can push in codes into the kernel. They are not so difficult to protect, but there are not many attempts. As soon as the user is in memory, the wicked user, then we should check the integrity of our code in the memory, block by block. If there is something else, or whatever is running is those parts that should really run, we should also check the checksums in some way. Service protection. We mentioned it several times. We should protect the registry keys which belong to the services. Registry keys are used to generate the service. For this we need a process manager, no any larger magic. It would be good not to delete those poor services. And there is a possible solution to this problem. Human anti-malware methodology. Antivirus products won't restart the computer. If we are investigating, and if I am made to sit on the computer to check it, there is something suspicious. If we have a bit more data and some files disappear, then the network traffic is larger. Then there is a methodology. We have a checklist. We sit next to the machine. If nothing is found, then probably the machine is protected, so there is no suspicious products or AV or rootkit on it. If we find something, then we can take it apart, give it to Linux, Windows, OS X expert, and this is the methodology that we use at our firm. It's also feasible and workable and functional for many systems, Linux, Windows, OS X. And then we have the asset demo. Questions? Not a ladybug.
Jó, nem érintjük hozzá a tetejéhez, így jó is.
This is the top. Here we have an asset product, a brand new one. C ending.
Ja, bocsánat. Van ott egy ilyen bad fájlunk.
We have a bad file, which should disappear as soon as kernel code is loaded. But let's start a task manager as well, and it should also disappear from the process list.
Itt látszik alul a task managerünk. Na most akkor azt mondjuk, hogy loader. Betöltjük a kernel kódot, és a task managerünk eltűnt.
Load the kernel code in, and then task manager disappears. There is a dir command issued here, and our bad file disappeared as well. Rootkit is being loaded in. It make a file and make a process disappear, and then in the background we have maximum protection, and then we can do the same for all the rest. And I will fill in the rootkit, and probably and hopefully the whole thing will be able to start.
Tart úgy, hogy lefagyott.
It lasts long, so it is frozen, or it got frozen. Thank you very much. This much is my presentation with my demo. Microphone, we can't hear the question. Hope that it will be repeated. I pulled up everything to max. The question was, what settings did I check? I pulled up everything to maximum. Heuristic and all the other things was pulled up to the maximum. Defense plus, so all the features were pulled up to maximum. That was it. Thanks.